Question for you. What would you do if your name was what?
Cabot!
Yeah, Marshmallow, how you doing?
You fixed me up with a date.
I sure did.
What is her name?
How did you know that?
I don't know what.
You knew her name was what? How did you do that?
Wait a minute. You got me a date.
I sure did. She's got a name.
What is her name?
Shirley.
Her name is Shirley?
No, her name is what?
Shirley.
Now you got it.
I got what?
Exactly.
Let me ask you this.
Sure, go ahead.
Where is what coming from?
She's coming from Des Moines.
That's 50 miles away.
Correct, but she's coming on horseback.
What is riding a horse?
That's right. What is riding a horse?
How should I know what's riding a horse?
I don't know. I just thought you might. I mean, after all, you knew her name, didn't you?
What is her name?
Yeah.
How fast does the horse travel?
With what on its back?
With anything on its back.
10 miles an hour, and it left 5 hours ago.
What left 5 hours ago?
To the minute.
Then where is it?
Why?
Why? Because I want to meet her, that's why.
She's not here yet.
What's not here yet?
Of course what's not here yet, because the horse stops every hour for 10 minutes to let what? Stretch her legs and get a drink of water.
What drinks water?
Sure, wouldn't you? I mean, it's hot outside. What gets thirsty?
I don't know what gets thirsty.
Well, you will know when she gets here.
When what gets here?
Certainly. Hey, do you know when what's going to get here?
I don't even know what's coming.
Well, look, we do know that if the horse stops every hour for 10 minutes, we know what won't get here in 5 hours.
What won't get here in 5 hours?
Of course not. Not if the horse stops every hour for 10 minutes.
What does?
Of course what does. Come on, how many times do I have to go over this with you?
Go over what?
Yeah, right.
Let me see if I got this straight. A girl is coming from 50 miles away on a horse that goes 10 miles an hour but stops every hour for 10 minutes, so Watt can get off the horse and stretch Watt's legs.
So far, so good.
After Watt has stretched her legs and had something to drink, Watt gets back on the horse.
That's right.
What's right?
Absolutely.
Absolutely. After 1 hour and 10 minutes, Watt has gone 10 miles.
That's right.
Good. Now Watt rides another hour.
Good.
What's good?
Of course what's good. Otherwise, Watt would never get here.
At the end of that period, Watt stops again for 10 minutes.
Sure, sure. Now, look it. That's a total of 2 hours and 20 minutes.
Watt gets off the horse.
Sure, how else is Watt gonna stretch her legs?
Stretch Watt's legs.
Be kind of silly for Watt to stretch someone else's legs.
After 4 hours and 40 minutes, Watt has gone a total of 40 miles.
Ah, now you're getting it.
That was an hour ago, so Watt ought to be here in 10 minutes.
Right, you see, because it has taken what? Not 5 hours to go 50 miles, but 5 hours and 50 minutes to go 50 miles because Watt stops every hour to rest for 10 minutes. You know, she's going to be tired when she gets here.
Watt'll be tired.
Oh, exhausted. So will the horse.
What's horse?
Yeah.
Well,
Hey, what's there?
I don't know what's there.
What's early?
I don't know what's early.
Wait a minute. What's not early? It did not take what? 5 hours and 50 minutes to go 50 miles, but 5 hours and 40 minutes to go 50 miles because what doesn't rest at the end of the trip for 10 minutes because what is there?
I don't know what's there.
Exactly. Why don't you stand there? Let what in?
What is it?
Hi, what's the name?
Hey, Cabot!
This just in. On the weather front, watch out for averages that are much too small. Film at 11.
We interrupt this program to bring you the latest news in the world of meteorology. Weather with weatherman Brainerd Lamont, already in progress.
Oh, it's raining frogs in Calaveras County, and the folks out there seem to be taking it in their stride. Fine people. Love them to death. Oh, have I mentioned Winona Wyatt? It's a double celebration for her out in Guadalajara, Maine. She is celebrating her 100th birthday and graduating from taxidermy school. She sent me this. A stuffed lobster, you gotta claw your way to the top. Way to go, Winona, and thanks. Now, back to the weather. Hey, are we having snow here or what? Overnight here at Square One TV, we received an average of 7.5 inches of snow right here on the roof of our building. So kids, get out your sleds and come on over. What an icy July. Now, maybe you're wondering how we figure out that snow average. Well, here's the guy that figures it out for us. A real precipitation nut. Love him to death. Our station security guard, Lester Bobrick. Lester?
May I see your ID, please?
Lester, you know who I am.
Doesn't matter. If you don't have the ID, you can't stay on the premises.
Lester, we're on the air.
Don't make me use the cuffs.
Okay, Lester. There you go.
A little slower, please. Thank you. Please wear it at all times.
Now, Lester, about the snow.
Oh, yeah. Well, see, what I did was I went up on the rooftop of the station, and I took my official security guard yardstick, batteries not included, and I measured the snow in 6 different places.
Now, why 6?
Well, you may think that the snow falls equally all over the rooftop, but in actuality, it is not the same depth all over the roof because the wind blows it all around. Now, you see, by measuring the depth of snow in 6 different places, I can find an average depth of snow. Ask me how I do that.
How do you do that?
Whoa, what an excellent question. Lights, please. Thank you, I love you too. Oh, you're sensational, baby. Now, here's some data that I've collected from my wonderful, fabulous, incredible trip up on the roof. Hit it, guys. Love you. Submitted for your approval. Just a little joke there, folks. Hey, at point A, I measured 11 inches of snow. At point B, 7 inches. On the way to the other side of the roof, I slipped. But hey, no problem. Didn't hurt one bit. I got my act together. And I measured 12 inches at point C. And only 1 inch at point D. Over at the center of the roof, a bunch of guys were having a snowball fight. Piece o' cake. Talked my way over to the middle. I measured 3 inches of snow. Then at the flagpole, my country, 'tis of thee. Interpretive version, folks. 11 inches of snow. Lights up. I love you. Please.
Hey. Yes, so I add up the numbers here. For a total of 45, I divide that by the number of times I measured the depth of the snow, 6. 45 divided by 6 gives us an average depth of 0.75 inches.
No, that can't be right.
Huh?
That's only 3/4 of an inch. All your readings were more than 1 inch, so how can your average be less than 1 inch?
Oh, yes, you're absolutely right. I read it incorrectly. It's 7.5 inches.
That sounds more likely. The average depth is 7.5 inches.
That's correct, and that average tells you how deep the snow would be if it was spread out evenly all across the roof.
Huh.
There, you see? 7.5 inches.
Oh, that's fascinating.
Yes.
Oh, we just received this note from the station manager.
Oh.
While you were up on the roof, someone stole all the typewriters from the newsroom.
Oh, dear. Well, I'd better get on that case right away. Thank you. Goodbye.
Yes, well, thank you, Lester.
Yes, and don't forget to sign out. Sign out. Goodbye.
Well, that's what's happening in the world of weather. Have a great day. Whoever you are.
Warning. While watching the next bit on Square One TV, if you tie the laces of your right shoe to the laces of your left shoe, by the end of the show, you will have forgotten about it, and when you get up to go to the other room, you will fall down and squish your nose. So don't do it.
Listen up, all you square pegs. I got a math rap I gotta do. It won't take long to sing my song. You know I wrote it just for you. Squares are simple shapes. 4 sides all the same. Squares are functional. More than some math game. Squares are really cool. Not just geometry. Squares, they work for you. get around. You got the right angle, we're talking squares. Ha! Crossword puzzles, window panes, album covers too. Postage stamps, bathroom tiles, that's just to name a few. Check out your calendar, you'll see them there every single day. Equal angles, equal sides, squares are everywhere. Hey, hey! Quadrilaterals are here to stay. Square units, square inches, square feet, square yards, square blocks, square miles, square dance! Square dance! Square, square, everywhere, on the ground, in the air. Squares, everywhere. Square, square, all around, in the house, all over town. Squares, get around. You got the right angle. Squares are never round. No matter how you look at them, they're upside down. Squares, squares are such a groove. Put 6 of them together and you get a cube. Squares, squares, squares everywhere. On the ground, in the air. Squares everywhere.
Square One TV, when you care enough to think the very best.
Square One TV's roving reporter asks another mathematical question of the person on the street. Today's question, what is a rhombus?
A rhombus? It's a 5-sided figure, I guess. No, it's 4 or 3, I don't know. A rhombus sounds like some kind of an animal.
A fish.
Some kind of fish that's in the ocean or something?
From the jungle.
It has to be something like a thing. It has to be like a shape or something.
I believe it's something to do with a frequency.
Similar to a parallelogram.
Something that a bunch of kids get together and have a little fight amongst themselves. Is that what?
A rhombus. Wasn't there a rhombus cube or something?
Yeah, it's a closed-sided figure with no 2 sides being equal or parallel.
A rhombus, that's easy. A rhombus is like a square, which have all sides that are equal, which has kind of been slanted over. And this angle and that angle are equal angles. That's a rhombus. Easy.
So, come on in for just a second.
Nice room.
Yes. We'll stand right over here for a second. Arthur, I want to show you and Beverly something with a deck of playing cards. You're familiar with playing cards, of course. There are 13 cards in each suit. And perhaps the one that we all remember most of all is an ace. Now, the interesting thing about an ace is that as you will shuffle a deck of cards and then mix them up like that, you can do that, and you'll find that there's another ace there, if you follow what I mean. In fact, if I were to just reach inside here, then I could find another ace like that, of course. And as you shuffle the deck and do that, you'll find that sometimes you'll even find another ace. So those are the things that happen. Now, what I want you to do, Beverly, is to take one of the cards there and hold it in your... I'll tell you what I want you to do. What I actually want you to do is this. If you will hold this card, hold out the palm of your left hand. That's this one over here, the good hand. Okay? Now,
when I write with.
Place your right hand on top of that and keep that card secure right there. Now, I don't know if you've ever seen one of these before, Arthur. Do you know what that is? That is a small one of those. But today we're going to use this size because it's a little easier to deal with. You see, what that is an imaginary die without spots on it. That way you can throw that and choose any number, and I'm going to show you something rather interesting that you can learn to do with our card, our die, and some numbers. Throw that and come up with any number from 1 to 6. Okay, now don't tell me what it is. That's your imaginary number. I won't peek. I want you to write it down on your pad. Right there, whatever number you've come up with. Now follow this formula. I want you to multiply your number by 2.
Okay.
Now then add 2 to that answer.
Okay.
Now multiply that by 5.
Times 5, okay.
Subtract the original number, whatever your number on your die is, that number. Okay?
Okay.
Have you come up with a 1, 2, or 3-digit answer?
A 2-digit.
Okay, now I want you then to add those 2 digits together. And what is the answer that you have?
I just tell you?
Tell me, please. 10. 10. 10 is the answer you have. Now, we had our 4 aces down here. You're holding on to one of the aces there. Yeah. You said 10. We changed that into a 10. See?
Whoa,
there it is. That's a 10 right there. How about that?
All right.
Very. Now, to explain how this was done, may I borrow your pad a minute? Sorry. You see, if you'll take any number from 1 to 6 on our imaginary die and follow this formula, your answer will always be 10. In other words, whatever number you start with, multiply by 2, add 2 to that answer, multiply that final answer by 5, then subtract the original number. You will have 2 digits that will add up to 10. You see? Huh. That's mathematics.
Oh. Mr. Blackstone, the Tigers, they've all lost their stripes.
Oh, that's terrible.
Oh, I'll tell you what.
Come on, we'll get a paintbrush.
Behind you. Yeah, that'll work. Hey.
So I, Jacques Cousteau, set out in search of the giant squid.
Sonar reading. The ocean floor is 28 meters. Très bien, très bien. And the rate of speed.
Due west at 20 knots, sir.
Excellent. Perhaps now is the moment we have all been waiting for.
You mean?
Yes. The moment we turn off that obnoxious music. Oh. A little bit of that goes a long way.
Excuse me, Mon Capitan. It's my first voyage, and I was just wondering.
Yes, my friend.
According to my calculations, we're very close to an iceberg.
How close are we?
10 centimeters.
10 centimeters. Sacre bleu, engines to reverse! Secure the hatches! Stop the ballast!
Louis Pasteur!
Hold the mail! Hold on, everybody, this will not be fun. Now, let me see this iceberg face to face. Something is fishy. Something is très fishy. Monsieur Navigator, where is this iceberg?
It's exactly 10 centimeters away, Mon Capitan.
Are you sure of this?
I'm positive. Come, look. See? This X on the map represents the ship. That's us. Then I found this triangle. That represents the iceberg. So I took this meter stick, and I measured the distance from the X to the triangle, and it measured exactly 10 centimeters. Take a look at for yourself.
But monsieur, 1 centimeter on a map does not represent 1 centimeter in the real world.
It doesn't?
Of course it does not. If 1 centimeter on a map represented 1 centimeter in the real world, then the map would have to be as big as the area it was mapping. A map of New Jersey would have to be as big as New Jersey. Try to fit that in your glove compartment.
I don't drive, thank you.
Now on this particular map, we have a scale of 1 centimeter to 10 kilometers. This means that 1 centimeter on a map represents 10 kilometers on the high seas.
Which means that when the meter stick reads 10 centimeters...
We have to do a calculation. If 1 centimeter represents 10 kilometers, then 10 centimeters represents 10 times 10 kilometers, which is...
100 kilometers, which means in actuality, this iceberg is 100 kilometers away. Oh, am I relieved? Thank you.
Formidable, you have mastered the map. Congratulations. Now back to your duties.
Fromage.
Yes.
Steady as she goes, Capitan.
Thank you.
And so we head out to sea. The little problem solved by mathematics. The ship sustained no severe damage, but...
Mon Capitan! Mon Capitan!
Yes, monsieur.
This fantastic. According to my calculations, the giant squid is only 240 kilometers away.
Très bien.
And our home port is only 25 kilometers away. My rubber ducky Melvin is 2,466 kilometers away, but my karate school is 16,824 kilometers away. Oh, and my chiropractor.
The story you are about to see is a fib, but it's short. The names are made up, but the problems are real.
It was 9:43 a.m. and the garbage strike was still on in New York City. Luckily, we were working the day watch out of Mathnet in Los Angeles. We were working on the problem of the passing parade, which had turned into a kidnapping caper. America's most popular rock star, Steve Stringbean, was missing. My partner is George Frankley. The boss is Thad Green. My name is Monday. I'm a mathematician. We decided to look at a couple of scenes from yesterday's show to refresh our memories. All we had to go on were some narrow tire tracks that proved to be made by an antique car, a celery tonic bottle with Stringbean's fingerprints on it, some music, and at last a phone call from the kidnappers. Eddie Rimshot Harris had an idea. A long shot.
Embassy recording. He's got to be there, man.
Your hunch is worth a try, son. It's all we've got to go on. Let's roll. Excuse me, sir. We're looking for embassy cleaners.
Uh-huh.
Know where we might find it?
It was right here. Burned down 3 days ago.
Word of Stringbean's kidnapping had leaked out to the press. Thad Green called us in to answer their questions. It wasn't easy, especially since we couldn't answer many of our own questions.
Ladies and gentlemen of the Fourth Estate, be seated, please. We're ready to answer as many of your questions as possible. With me are Kate Munday and George Frankley of Mathnet.
Hi. Have you heard from the kidnappers?
Yes, Tom. Kate has spoken with them.
They have issued a ransom demand.
What happens if they don't get it?
I'm afraid they said we'll never hear Steve Thrush again. You know, sing. Yes, the reporter in the red tie.
Mr. Frankley, isn't it true you have used mathematics to try and find Stringbean's whereabouts?
Sure, Dick. We've used geometry, maps, even hunches to solve this case.
Well, follow up, please.
I'd rather you let the other people have a chance.
Yes, the newsman in the red tie.
Yes, what kind of math have you used to apprehend these despicable criminals?
Well, Harry, we used mapping which led us to their hideout, but we arrived too late and they'd already gone. We've used geometry, estimation, statistics.
But nothing has worked.
Not so far, but we'll keep trying. Yes, sir, the news anchor in the red tie.
What is the first thing you do in a case like this?
Get as many facts as we can.
Then we try to come up with a hypothesis, a possible solution. Just having facts without knowing what they might mean isn't much help to us. Help-wise, I mean.
Have you gone down many blind alleys?
Yes, but that's usually the way with problem-solving situations. Solutions just don't jump up and bite you on the bottom. You have to earn them. Ladies and gentlemen, thank you very much. Now we're really going to be under pressure. I want this case solved, and I want Stringbean returned safely.
I couldn't agree with you more, Chief, and if it's any consolation, sir, Martha feels the same way.
Mathnet, Monday. Yes. You want the money delivered how? And when? Yes, all right, I've got it. How do we know Steve Stringbean is all right?
Please do what these people say.
All right. All right, it will be done as you ask.
I recorded it, Kate.
It's like he's tipping us off. Like he's singing a message.
George, they want the money frozen in a 350-pound block of ice.
Ice?
And then you know what they demand?
A very big glass?
They want it pushed off the pier at Santa Monica at exactly 12:01 a.m. tomorrow.
Huh. A minute past midnight. Remember the good old days, Kate?
when kidnappers just ask you to put the ransom money in old hollow stumps and things like that?
This is bizarre.
Please do what these people say.
What can these guys be thinking?
I don't know unless... Hello, Harbor Patrol? Kate Mundy, Mathnet. Fine, thank you. And you? Good. The reason I'm... What? Yes, it is interesting work at times. That's true. Mathematics certainly does influence our daily lives. Now, if I... Thank you. Could you tell me the tide tables at Santa Monica for the next 18 hours, please? Uh-huh. Uh-huh. Thank you.
Got something?
It's high tide at 12:01 tomorrow morning.
They want a 350-pound block of ice dumped into the ocean at high tide.
Can we figure out how far and where a 350-pound block of ice will float before it sinks?
I can't.
Maybe we can make an estimate. We'll need to know the speed of the current, the winds.
Uh-huh. And the water temperature, and how fast ocean water will affect ice.
It's inexact, but it's the best we've got.
Maybe we have something to go on, mathematicians. I wrote down the notes that Steve sang.
We're kind of busy right now, Rim.
Wait a minute. Every note in music has a corresponding alphabetical annotation, man.
Huh?
See this note? It's an F.
I see. You think he might be trying to spell out a clue for us, Rimshot?
Maybe. But the next two notes are F's also.
What word begins with FFF?
I don't know, man, but here's the rest of the notes. E flat, G, F, E flat.
F, 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 E flat, G, F, E flat. Efficafe. That doesn't spell anything.
Nice try, Rimshot, but I'm afraid it doesn't mean much.
What I still can't figure out is, why he's singing off key?
Well, he may just be nervous. It can't be much fun. Being kidnapped, I mean.
George, get the lab working on our ice problem.
Right.
That's it!
Steve Stringbean is singing the kidnapper's telephone number.
$10,737,418.23. Really?
He's got to be our man. Let's roll.
440, 450, 21. The tires fit, Kate.
100% of Square One TV is a production of the Children's Television Workshop. This program was made possible by grants from the National Science Foundation, the U.S. Department of Education, the Corporation for Public Broadcasting, the Andrew W. Mellon Foundation, and the Carnegie Corporation of New York.
Corporate funding is provided by IBM. At IBM, we believe education is the key to the future. We are pleased to help support Square One TV as an innovative way to introduce young people to the exciting world of mathematics.
New garden salad.
The 41st Annual Tony Awards will continue.